Hello, Junior Takis, a warm welcome. This is your host, Mr. T, and it brings me joy to be presenting to you a grade 10 lesson on Euclidean geometry. This will be a practice video, and so get a pen and a paper. Try to attempt to answer these questions before we review the solutions. Without any waste of time, let's get straight into the first question. We are told that in the diagram below, PQ is equal to QS equal to SR equal to SM, and that PS is parallel to QR. Prove that, number one, that R2 is equal to P. So to prove that R2 is equal to P, I'm going to start by working in the following triangle, the triangle SQR. In that triangle, because of these marked sides which are equal, it follows that that triangle is an isosceles triangle. And again, because it's isosceles, it follows that the angle Q1 has to be equal to the angle R2. So my first statement would be the angle R2 is equal to Q1. The reason for that, it's angles opposite equal sides. I then move on to making use of my parallel lines. I'm going to state that the angle S1 has to be equal to the angle Q1, and this follows alternate angles. Those two alternate angles are equal. So my next statement would be the angle S1 is equal to the angle Q1. The reason for that is alternate angles, the PS parallel to QR. I then make a conclusion and work in the last triangle, which is that triangle over there, the triangle PQS. In that triangle, again, because of the marked sides which are equal, it follows that it's an isosceles triangle, and because it's isosceles, the angle P has to be equal to the angle S1. So my next statement, to formalize it, I'm going to say the angle S1 is equal to the angle P. The reason for that is angles opposite equal sides. Finally, I make a conclusion and say, therefore, the angle R2 is equal to P, which was the required proof. We move on to the next question. In our next question, we are required to prove that triangles PQS is congruent to triangle RSQ. So we are required to prove that triangle PQS is congruent to triangle RSQ. So this is your RSQ. We want to prove that it's congruent to the triangle PQS, which is that triangle over there. Now, how do we prove that those two triangles are equal? We might as well make use of the information that we proved in question number 1. So I'm going to start by saying that the angle R2 is equal to the angle P, and we have already proven that, to say that angle R2 is equal to the angle P, which is exactly what we would have done from question number 1. The next point would be to state that, and that was proven as a reason, but the next statement would be to state that S1 is equals to Q1. Again, that we have already proven, if you recall from the first question. So that's a proven already. But if you look at the two triangles in question, they share the side QS. It's a common side, and therefore I state that QS is equals to QS, and the reason it's a common side. You state common side. Finally, you make a conclusion to say, therefore, triangles PQS is congruent to triangle RSQ. The reason for that is side angle angle. We move on to the third question. In our third question, we are required to prove that triangle PQRS is a parallelogram. PQRS is a parallelogram. Now, to prove that it is a parallelogram, we can start by stating that the side PQ is equal to the side RS. And where are we getting it from? It's a given. It's from the original statement right at the top. Also, we know that the side PS is equals to QR, and that we have already proven through congruency. So that's a proven. Then finally, I can make a conclusion and say, therefore, PQRS is a parallelogram. The reason for that is that we're having two pairs of opposite sides being equal and parallel. We move on to the fourth question, where we're required to prove that PT is equals to 3ST. To do that, we start by saying MT is equals to TR. The reason for that is that we know that ST is parallel to QR and MS is equal to SQ. Think about it. ST is parallel to QR and MS is equal to SQ. You might want to mark that on the diagram if it helps you. We move on and say, therefore, the side ST is equal to half QR. Where are we getting that from? It's because we're using the midpoint theorem. That is the midpoint theorem. We know without a doubt that the point S, that point and the point T, they are midpoints of those respective sides. So we are looking at the big triangle MQR. Our next step from that, we can say QR is equals to PS. The reason for that, it's opposite angles of a parallelogram. And finally, we say ST is equals to half PS. And if that is the case, we now say PT is equals to 3ST. We move on to the last question, where we're required to prove that the angle MRQ is equals to 90 degrees. To prove that MRQ is equals to 90 degrees, we start off by saying that R1 is equals to M. The reason for that, it's angles opposite equal sides. Angles opposite equal sides. We then move on to the following statement, where we say M plus R1 plus R2 plus Q1, that should give us 180 degrees. The reason for that, we're dealing with interior angles of a triangle. Interior angles of a triangle. Think about it. We're looking at this big triangle over here. That big triangle over here. If we add that Q, if we add R1, R2, and M, we must get 180 degrees. Interior angles of a triangle. But we know that R2 is equals to Q1. We know that R2 is equals to Q1. And if that is the case, we can say, therefore, obviously that's angles opposite equal sides. And if that is the case, we know that 2R1 plus 2R2 must give us 180 degrees. If I divide that equation in purple by 2, the resulting equation would be R1 plus R2 is equals to 90 degrees. And therefore, I can make a conclusion to say, therefore, MRQ has to be equal to 90 degrees. I hope you enjoyed that lesson. Until next time, bye-bye.